bucka. Haha. You know the deal.
Next, with volume and surface area, is the volume and surface area of a cylinder. A cylinder is similar to a prism in that what we have here is a base, a bottom, and a top that are the same shape and exactly the same size. The bottom is a circle and the top is a circle. So that circle travels from the bottom to the top without changing size or shape. So the nice thing about that is that means that we have a very similar equation for the volume of a cylinder as we do for a volume of a prism, in that we can simply calculate the area of the base and multiply it by the height. Because when we calculate the area of the base, that'll tell us how many square centimeters in this case are on the base, and then the height is the number of layers of square centimeters that we have. So we multiply the area of the base times the height. So if we look at a cylinder, a base is a circle. To calculate the area of a circle, we multiply pi times r squared. So that's how we calculate the area of our base, and then we take the area of the base and multiply it by the height. Well, if we substitute our values into the equation for this cylinder, pi is 3.14. Our radius here is 3. So we're going to square that, and then we're going to times that by the height. Now, one thing that students often forget here is to follow order of operations. And in this equation, we have to do the exponent before we do any of the multiplication. So we're going to solve that first. So to do 3 to the power of 2, that means 3 times 3. 3 times 3 is 9. And the height here, of course, is 10. So we're going to multiply the answer to the area of the base times 10. So now when we multiply 3.14 times 9 times 10, we get 282.6. And because we're measuring volume here, we're measuring the size of a three-dimensional shape. That means that it'll be in units to the power of 3. So again, calculating the volume of a cylinder is pretty straightforward. We've developed our equation here, which is pi r squared times the height. Substitute in our values, follow order of operations, which means we have to do exponents first, then do the multiplication, and remember to include the unit in your final answer. And unit will always be to the power of 3. So the next thing we're going to talk about with the cylinder is calculating the surface area. And again, just like a prism, when we're calculating the surface area, it means we're calculating the area of all of the sides. So let's start by talking about what the sides of a cylinder are. Well, as we talked about already, the top and the bottom are circles. So if I'm going to break up this shape into its pieces, the top is a circle and the bottom is a circle. And they're circles that are exactly the same size and shape. Now, the rest of this cylinder, there is a bit more to it, and the rest of it is this sort of curved area that we have here, sometimes referred to as the lateral area. And looking at the cylinder, it's a little bit hard to tell exactly what that shape is. But usually if I do this lesson in class, I'll actually take a piece of paper, and you can take a piece of paper and kind of roll it together to make a cylinder. So when you unroll a piece of paper, it is a rectangle. That's the shape a piece of paper is. So when you unroll that lateral area, what's left other than the two circles, you end up with a rectangle. Well, when we're calculating the area of a rectangle is length times width. So here's our length and here's our width. But on a cylinder, we don't really have a length and a width. Let's start with the width here. If we, again, think about this like a piece of paper that we're going to fold together, we would start with this corner and kind of wrap it around to meet with this corner. Well, our width here is actually our height of our cylinder. So our width really is the height of the cylinder. And the length here, if we look at the cylinder up here, if this is our corner of our piece of paper, and if we're going to wrap that around and have it meet back up with the corner, well, that wrapped around circle there, the distance around that circle is the length. and the length is actually the circumference of the circle. So let's talk about an equation to calculate the surface area of a cylinder. Well, as we talked about initially, we've got these two circles here. To calculate the area of a circle, it's pi r squared. Well, the two circles are exactly the same size. So if we want to calculate the area of both of those circles together, we multiply that area times 2. To calculate the area of the rectangle, which is the lateral area, it is length times width. But as we've discussed, we don't really have a length and a width on a cylinder. It's the height times the circumference of the circle. So that's how we calculate the area of the rectangle. Now, we're usually not told what the circumference of the circle is, so we actually have to calculate it. And the equation to calculate the circumference of a circle is diameter times pi. So to get that lateral area, we're multiplying diameter times pi times the height. That's our length and that's our width of our rectangle. So here we've got the area of the two circles. Here we've got the area of the lateral section, the rectangle. To get the total surface area, we're going to add those two areas together. So if we take a look at this example, now that we've developed that equation for surface area of a cylinder, let's just go ahead and substitute in our values here. So we'll start with a 2 pi r squared part. So pi is 3.14. Our radius in this case is 3. So that's how we would calculate the area of the two circles. And then the area of the lateral section, the rectangle, is the circumference times the height, and to calculate circumference, it's diameter times pi. Now here, our radius is 3 centimeters. The relationship between the radius and the diameter is the diameter is always twice the radius. So if the radius is 3 centimeters, the diameter is 6 centimeters. So we're going to multiply 6 times 3.14 and then multiply that by the height, and that'll give us the area of that rectangle, that lateral area. Well, we do have to follow order of operations here, so we're going to do the exponent before we do anything else. That's what comes first in bed mass here. We don't have any brackets here. Here the brackets just indicate multiplication. So 3 to the power of 2 is 9. And we'll just leave everything else exactly the same. The diameter again was 6 times pi times the height. Well, if we continue to follow order of operations, the next thing we have to do is the multiplication. We can go ahead and do all of the multiplication here and all of the multiplication here. And when we do those two multiplication questions there, 2 times 3.14 times 9 is 56.52. 6 times 3.14 times 10 is 188.4. And then all we need to do is add those two areas together. And now that we have our final answer, we do want to include the unit in our final answer. Because we're talking about area here, we're talking about the size of a two-dimensional shape, so it'll always be in units to the power of 2. So to finish off our lesson on calculating the volume and surface area of a cylinder, I want you to go ahead and give it a try for this cylinder. So calculate both the volume and the surface area of this cylinder using the equations that we developed in this lesson. A couple of things to be careful of here. The 8 meters there, that's the diameter of the circle. The 12 meters is the height. And the unit is in meters. So make sure to include the proper unit for your answer for both volume and for surface area.